So the first video that we saw basically went over how to do the the 8 queens problem. Now, the 8 queens problem is an extremely classic problem. It is extremely well known in computer science and has been given as homework for God knows how long, but it's still a good idea. But this is because it builds a skill and teaches you how to use recursion for something called backtracking, recursive backtracking. It does this exhaustive search, essentially. And it is a smart way of searching for a solution. There are basically 2 ways you can kind of just blindly search for a solution. One is brute force, which always works, which is simply check every single possible solution and see if that works. However, for the chessboard problem, right, that would mean basically if you know your prob stat, that means it would be 64 choose 8 possible positions, right? Or not 64 choose 8, sorry, my bad. That would be 64, right? We times 63 times 62 times 61 times 60 times 59 times 58 times 57 possible solutions that we'd have to check. However, a lot of branches, for instance, a queen here and a queen here, it doesn't matter where the rest of the queens are. We shouldn't have to check that because those are automatically rendered invalid based on having 2 queens here. So finding a solution using brute force, because a brute force solution would give you a lot of redundant solutions. We'd have queen, 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 and whatever. Queen, 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 and whatever. Queen, queen, and basically all possible ways that this could go. It also could be a queen here and a queen here, and you get the point. Brute force, while it will work, that's an eventual kind of work. Not the most promising. All right, so using this exhaustive search using backtracking, we've got this algorithm that will basically cut off a branch if we see we see it's not going to lead to a solution. And again, with recursion, all we're doing is making sure is that we're trying to make this a local solution as much as possible. I give you 2 choices as to what chess problem you want to use. You can also do the Knight's Tour problem if you want to, but you've got 2 choices as far as your chess problem. Sudoku, you don't get a choice on. You got to do Sudoku, which I'll go over in the separate video. But for 8 queens, right, you've already seen the video on it, and you've seen what we're doing. So let me just kind of go over this algorithm. Now, this algorithm will be used for both the chess problems and our Sudoku problems. So basically the idea here is that we want to solve some board for this. We want to solve some board. Now the board is typically going to be an integer array here. And the position, that can be one variable or multiple variables. In Sudoku, that will be our column. No, sorry, not in Sudoku. In the chess problem, in the 8 queens problem, this will be our column. So if position is such that nothing is left to solve, if we've gotten to the end, so for instance, if we went to the off the board in our chessboard, right? For instance, if we're trying to place a queen in this column, then return true. Otherwise, for each possible choice, if that's a valid choice we can make, we mark the board at position with that choice, and then if we can solve the next position, if that returns true, then we will return true. Now, if we basically say solve just my column, and then I'm going to tell the next column to solve the whole board, and he's going to do the same thing, and so on and so forth. So if it returned true, that meant whoever the next column called returned true, which meant that whoever the next column called returned true, and so on and so on. So that meant we hit this terminating condition. So that means that somebody returns true, was returning true all the way through. On the other hand, if I put down my piece over here, right? If that does not lead to a solution, then what I got to do over here is that actually I should probably clear that choices over here. This over here is better for Sudoku at this position. This line can be either here or after the if statement or after the for loop. After the inner if statement, that is. But it over here, basically, we put our piece down. So if we put our piece down, we'll want to pick it up in this case. Now, basically, if I go through all possible choices in my board, right, for every possible choice, if it's a valid choice, right, so we go through and nothing worked, or we run to a valid, we got to a valid position, but it got us to a dead end, right, then we're going to have to return false. And that will signal over here to anybody who called us, right? This will signal over here, oh, I'll have to pick up my piece and keep going, right? So for more details, watch the video that we went over.